So, standing room only. Good morning, everybody. So my name's Chris Auld. I work at Microsoft here in Singapore covering Asia Pacific with a team that basically builds the sorts of things that you saw in the previous session. I run an engineering team that focuses on customer enablement engineering, so going and working with engineers and some of our large global customers, helping them build interesting solutions. So it was quite funny because just this morning was running a session with a company talking about entity extraction, disambiguation, and relationship building. So pretty interesting. So I'd like to introduce the team and maybe have them introduce themselves. So let's wander down and maybe start with Oliver, who is mic'd up.
Okay.
Who's not mic'd? Just Ayesha.
Okay. You're special, yeah.
Okay, my name is Oliver. I'm the CEO and co-founder of ViSenze. We're an artificial intelligence company. It's computer vision itself. Sorry, I'm nursing a little bit of a cough, so don't mind my soft voice itself. But essentially, this company that we've built focuses on processing intelligence in pixels and in images in order to extract that and help people understand the visual world a lot better.
And Ofer?
Yeah, so my name is Ophir. You cannot see my picture. There's no intention there. I'm not hiding or anything. It was a last-minute change here. So I'm the CTO of a company called CXA. We are helping basically to transform the employees' benefit domain using a lot of AI and machine learning in order to provide smart recommendation and optimizing the customer experience. Yep.
Hi. Hello?
No, it's not, I think.
It's not working. Come on, just check. Shoot.
That looks good. That sounds. Try that. Try that.
That?
Oh, no, maybe. Yes.
You want to use
Slow.
Oh, okay, thank you. Hi, everyone. I'm Ayesha Khanna, and I am co-founder and CEO of ADDO AI. And we are an artificial intelligence consulting firm. And we help governments and companies, such as transportation companies or the government of Dubai, personalize and automate their customer experience.
Hi, my name is Ettikan. I'm from Nvidia. So my role is I work with developers, regardless the size of the developers, who transform problems, natural problems, or whatever problems that they have into something which is useful for the humanity, for the business, and so on. And I'm glad to have ViSenze and also Adatos as well, two of the startups from Nvidia Inception program on the stage. So this is an example of Nvidia engages with larger ecosystem startups in the AI space.
I'm Drew from Adatos. We focus on trying to build AI that builds AI, something that Richard was kind of alluding to, getting into that master algorithm focus. We used to do a lot of different use cases across industry, over 122, 10 different industries, fintech, medical imaging, et cetera. Today, we only focus on one, which is taking satellite and drone images from up there to assess things on the ground, specifically in agriculture for food security, because I decided if I was going to focus on AI, do something that's really critical and relevant across, rather than the other ones, which ended up for me being more of a distraction for the revenue stream, as opposed to something that really we all need to be doing.
Thanks, guys. So it should be a super interesting conversation. And we probably need to put the Slido slide up. And if you ask some questions, we'll probably share those with the team. But I prepared a few earlier, like any good home chef. So who got some GDPR emails recently? Anybody? So it was a pretty noisy last Friday from memory. And one of the things that you find when organisations regulate, particularly organisations that tend not to be run by informed technologists, regulate technology, is that there are unintended consequences. So one of the things I'm pretty passionate about is the idea that we really need to take it upon ourselves as technologists to take active steps to protect customer trust so that we protect the sorts of innovative solutions that we can build. So I'd love to hear from the folks, what are some of the sorts of things that we can actively do to protect that user trust? Because I think once we've lost it, we're probably not going to get it back. Maybe Ayesha?
Sorry.
Yeah, we are going to share it.
Well, I think it's really important, both for consumers but also for enterprise organizations, to understand how these models have been built. And it is a fact that you can do some sensitivity analysis. There's a framework called LIME that gives you some indication. There's explainable AI. So at Google, they're also using visualization. All of these techniques can give people some insight on why the model came up with the answer that it did. And then you can use some of the things that Salesforce was talking about, which is to actually communicate in plain and understandable English why those decisions were reached. I find that this is a huge problem, an impediment, for two reasons. One, either the organization is so distrustful of the algorithm that it doesn't want to actually use AI, or the other issue is that it treats it completely as a black box and it doesn't question it. It doesn't question its bias. And both those things are not good for actually getting to the end product that you want, which is something that is trustworthy and customer-centric.
And it's certainly one of the challenges of many of the more advanced machine learning models is, you know, on the other axis to performance sits explainability. So we really have seen some interesting innovation of late around that. Drew, maybe some thoughts from you.
Sure. You should just mentioned transparency, which is definitely the important part. But as Chris was alluding to, once you get to the more advanced artificial intelligence capabilities where you are building single algorithms, many perceive it as a black box, and that's not particularly true. If you have the computing power, which we're very grateful with Nvidia and their involvement with the US Department of Energy, with IBM, Nvidia, and that program at Summit and Sierra, et cetera. Today we have that computing power where you can have full transparency. But that's one of the limitations. You need that type of computing power. But I would say that it's much more deeper than the issue of just transparency. Let's just assume technology-wise you can have transparency. There's an interesting study from a Judeo-Christian perspective in the West, that particularly in the West, the idea of an entity without a soul taking a bite out of the fruit of knowledge and having the ability to decide is essentially evil. We don't have that issue in the East. We look at things very differently. But this is one of the reasons why you have, like, for example, Musk, Gates, et cetera, saying, hey, the existential threat of AI. So when we deal with different companies, these ideas or the pushback on the privacy, the transparency are just on the surface. You have to address something much deeper, which is rapport of understanding the symbiotic relationship between man and machine, that it's a helper. Until you get over that, you're going to have the regulatory issues, you're going to go through all that, and at the end, the probability of you commercializing an artificial intelligence solution is pretty slim because the key decision maker is simply not comfortable with it. So we got to get over that, and we have to create those mechanisms, and that's education, right? That's awareness, that this thing is not evil. It's what the maker makes out of it.
Are we missing simple opportunities? I mean, are there simple opportunities to take advantage of pre-existing data, simple algorithms that we're maybe missing at the moment inside organizations? Ofer, maybe?
Yeah, so I fully agree, and I think there is a question here about AI and hardware and so on. So not everything is deep learning, not everything is GPU intensive. And I think one of the issues that I see with the recent hype about AI that you tend to look into the Googles, the Facebook, the Microsoft with the professors and with the huge access to hardware and compute power, and then you just give up. And you say, since I do not have any of it in my organization, I cannot do AI. And I think it's a mistake because they are very flexible and very powerful algorithms, support vector machines and others that can run on a simple laptop. and can use a relatively small data set. So I think we should try to shift the discussion from what technology are we using into what problem are we trying to solve. And rather than saying deep learning is the solution, what is the question, to try to think what problem are you trying to solve, and then to apply the appropriate algorithm or tools in order to solve this problem. And I think you were touching on the complexity of the algorithm versus the intelligibility of the algorithm, the ability to trace and to understand what went wrong. And there is a trade-off there as well. Okay, so to summarize, it's not all about very complicated and CPU or GPU intensive computers. You can run very good algorithms in your small shop and to get some great results. Yeah.
I'd like to add to that. So it is the use case, right? And I would argue that AI is overkill for the majority of use cases. And certain AI, for example, what Alder does and what they do in 6A, you can use this and get benefit immediately without trying to do something that is outside of maybe the current available skill sets that you're able to recruit, right? So it's the use case.
Yep.
And there are some fantastic skill sets out there. Think about looking for folks from the life sciences. Think about looking for folks from psychology. Think about looking for folks really who understand the experimental method, who value research. Those are fantastic people to bring into your organization and have work on some of these problems.
Yep.
And I'd also like to add to that people sometimes, everybody's gone and saw the movie Black Panther. And so they either expect magic out of the box, or they think it's some long, laborious, multi-year investment. And speaking exactly in agreement with my co-panelists, I think that one can start with a relatively, doesn't have to be a mega huge data set that Tencent would have, but one can actually have some ROI and show some results in up to a couple of months. And I think that's one should start small. Some people also get overwhelmed they get so excited by data that they're like, oh my God, but there's so much data and I have to redo all the data across all my firm. But that's also not the right way to start. I think the right way to start is to start with some subset of data and try to understand how that's useful. And then in a kind of iterative manner, it kind of percolates that methodology throughout the firm.
Fantastic. So we have got some hardware folks here. So let's talk a bit about hardware. Because really, there have been synergies over the past probably 15 years in terms of availability of data, development of algorithms like recurrent neural networks and convolutional neural networks, and the explosion of the capability of hardware, in particular, graphics processing units. So what are we all seeing in terms of the next evolution of hardware?
So we can start.
You try that?
So Nvidia is not a hardware company. We sell hardware, but 80% of engineers are software engineers. Software powers the hardware. So without you guys who are writing the applications, hardware, even we have the super fast machine here, which is we call DGX2 in the world that we have for all the AI training. It may not be in a good use if we don't have you to write the software and algorithms. So to come back to the question, the challenges are like this, right? So from the business perspective, I agree, the use case or pain point is what you need to address. The business could be satellite imaging problem that you have. It could be autonomous driving vehicle that you're trying to build. It could be some autonomous machine underwater. It could be as simple as deciding whether I should take this food or not because the calorie amount is so much and so. Or it could be as simple as a specific task robot arranges things in the rack. Whatever it is, find your pain point and have a business objective set, right? That's one part of the pillar. The second part of it, the algorithm comes in, right? So if you look at algorithm, complexity of algorithm varies from whichever algorithm you're looking at. Today we have one-shot approach, we have capsule NAT. You just name it, Jeffrey Anton started the capsule NAT work for a couple of months already since announced late last year. If you have CNN, RNN, you name it, right? So these algorithms, how do you take it? Do you take from open source, you start using it without you understanding it, without you evaluating it, then there's a risk. Or if you start from scratch, or you're taking transfer learning approach, you learn, you train in a different domain and you want to apply it in a different area, then how do you trust the algorithm? That's different sets, right? So you need to know the business point of view, the technology point of view, right? So let's look at a technology point of view. From Nvidia, we challenge ourselves every month, every day, every hour, so that every 6 months, if you see, or every 1 year, we almost have 10 times better performance from our GPUs. The reason is why some of the tasks are very simple. You could run inference. There's two part of it, training and inferencing. So training needs more amount of data sets. What is more, what is reasonable is up to you to decide. Depends on the complexity of a task. If it's a very crucial task that you're trying to perform, then you need sufficient data set to train. So from our perspective, our own work that we do in the lab, some of the industry came back and say, look, I need to train trillion over hours before I could say this particular model is suitable to deploy in a production environment. So when you talk about trillion of hours, we want to get it done in matter of hours to get the whole training done. So you need a large compute capability. For example, this GX2, which has 16 GPUs interconnected with a 300 gigabytes per second connectivity to have a neural network to train. That's one part of it. You can go all the way to a very small form factor where you're training probably not so much, you can have less compute power. And the other pillar is about inferencing, getting it executed. So small compute form factor is enough to get the execution done because you're purely traversing through the neural network. It could be VGG, it could be CNN, RNN. You can decide whether it's a 10 layers, dense net, sparse net. Based on the layer and the node you're going to traverse, you may want to do it within 7 milliseconds for execution. Or you're okay, you can wait for 7 seconds, up to you. You can find. So the compute part of it, it is sufficient and it is definitely available for any of you to do it, regardless whether it is an enormous task or simple task. But come back on the software part of it, I would say whether you want to trust the algorithm or not, it's up to you. Of course, in terms of research perspective, there is an explainable AI, work is being undertaken, so that mathematically AI can be proven. And you can explain to the bankers and say, look, if I use 20 parameters, or I let the AI to decide there is a 2,000 parameters to say this particular model is applicable for a scenario, you can explain. The work is ongoing versus what people are trying to do in machine learning, which is handcrafted. So it's a different approach, different techniques based on the problem. You can address that at this point of time. I'm very confident today AI can solve a specific problem better than human being. But you define what is the pain point and what is the problem they're doing to address.
Oliver, what are some of the interesting opportunities that you see to use new hardware, new models, new sets of data to innovate in your business?
Yeah, I mean, there are different applications that we can actually apply over here. I mean, software can't exist without the hardware. I mean, the fact that we are here in an AI world today, we're here in the AI world today with the massive explosion of unstructured data, and how do we process that? If you look at how we got here, essentially, it's due to the availability of stronger hardware, more powerful hardware, at cheaper cost, of course, on a unit cost per compute itself, as well as the ability to apply these compute power at scale. So some of those applications that we are already experimenting with are not just in the cloud or on-premise itself, but it's actually on the device. All right? This device that we have in our pocket itself is actually a very powerful device, because for some level of AI to exist on the device, not in the cloud, not on some hard servers itself, just on the device itself, you need to have higher processing capabilities. So we've been working with some companies, I can't mention who, essentially, where the TPUs on the device itself is smart enough to be able to detect and do some level of processing, to give out some level of intelligence. Like, for instance, in computer vision itself, we're able to then detect, without uploading that image into the cloud, what an object in this image means. And that's very powerful, given the fact that when you have like a range of data that you want to be able to process and return to the user, if the compute power is not strong enough, you'll be waiting pretty long for the output to come, and that's not a good experience.
It's one of the things we've been working quite hard on, is really pushing that inferencing out to the edge of the network. So we're using a technology called field programmable gate arrays that are basically programmable silicon. And so we'll train the model in the cloud, typically on a very large number of Nvidia GPUs. And then we'll quantize that model. So we'll effectively remove a significant amount of complexity and capacity out of the model. And then we're able to burn that model into reprogrammable silicon. And our goal is to be able to do that both in our data center, so that we have really high performance streaming inference, but also push it out to the edge of the network. And the thing we're most keenly focused on there is power. The biggest problem you get when you really start pushing out to the edge is power efficiency. Great to have Nvidia GPUs, but they're like 200 watts. So they don't last very long on a little battery.
We have also 20 watts.
Yeah. Yeah.
You decide what is your compute capability, right?
Exactly.
So if you have a power hungry problem, then you're going to have right solution. You have power lean, right? So for example, we have a Xavier, which we launched it last week. We can do 20 times better capability than TX2. And some of the robots out there that I've seen, they need such kind of a compute, because in order for robots to move, you need to have LiDAR, you need to have cameras. So the amount of data that you acquire so that you can make a decision, it is different than a mobile app which may do recognizing a simple food recognition, right? So the complexity ranges from problem to problem. It's difficult to quantize a specific power number from a specific architecture. It depends on the problem you're trying to solve.
Absolutely. What about SMEs? Who's from a small, medium enterprise? Who would consider themselves from a small business? This is the interactive session to find out if you're all awake. We're going to talk about SMEs? So you guys are all from great big companies. Yeah? Oh man, okay. Well, let's talk about
Chris, I'd like to tackle that on the commercial use, right? Because at the end of the day, if you're thinking of it, it has to be at least have a return on investment. Unfortunately today, most of AI is almost in the lab phase or innovation phase, or a scientific lab experiment in somebody's garage, or innovation program that's being funded by a couple of million in some corporate, right? So that's the reality. The challenge is, let's just say that you can get the data, you have the computing power, you have the culture to accept it, et cetera. You're not scared that if I implement this, I'm going to have to lay off people and my stock price is going to go south. All these complex things come into play. Is it profitable? Ends up being the question. And if you're highly dependent on a very scarce resource of data scientists and spend a lot of time, let's just assume your data is good enough to be used, right? You might go through a whole year and find out at the end that for $1 million, I'm going to make 100,000. Where's the ROI there? Or you make $1 million and 1.1 million. Why did you go through a whole year to make 100K? You're better off just putting it on the market, use your AI trade on it, which is actually more than 25% of AI is used for trading. That's out there, but nobody talks about it. That's very interesting because it's immediate return on investment. It's not like, if I use this, the market's going to adopt this a year from now, and then I'm going to fill my coffers, right? It doesn't work that way. The very interesting thing about that return on investment is, unless you have some kind of a roadmap to harness this for a use case that is extremely profitable in the hundreds of millions, it's just a lab experiment. And unfortunately, from my limited experience of going with a number of, over 100 use cases, people are more interested in seeing AI work than thinking out that if it does work and gets out of the innovation lab, how can we monetize off it? If you don't have that, planned out, you're going down to this interesting first question: is China winning the AI race? Well, if your motivation is to be dominant over everybody else in that space, you're going to fund it in a certain way. I would argue, like last year when I was trying to recruit practitioners, I couldn't find anybody in the United States unless that individual took their undergraduate in mathematics in mainland China and then took their PhD in the United States. What happened to the talent, right? I mean, I'm blown away. What was going on there? Why is there such an asymmetry on what's available and talent to execute these more complex things? But it comes down to your use case. It better be profitable, or you're just there because you're curious. I want to see Ex Machina, Terminator, blah, blah, blah. You're not in business.
So, Ofer, your thoughts?
Yeah. So I think for the SME, I think it's something that as a CTO I'm dealing with on a daily basis, the build versus buy. So I don't think that you need to build everything yourself. And the point is that if you can find a product that can do 80% of what you need, don't hire the data scientist, don't go through the process. You have 20 employees on your payroll, you have a P&L issue, you have a cash flow issue. The last thing that you need right now is another expensive resource. So I think if you can find platforms that are aligned, basically solving your problem, just pay the license fees, and I think it's good enough. Yep.
Yeah, I mean,
Yes, sorry.
Yeah, I would totally agree with that. I think that one of the things that I've been advising some agencies in the government is to subsidize access to ready-made libraries and platforms so that it is easier for SMEs to experiment with this. And instead of having 20 data scientists, maybe you just need one. And maybe you can have a consultant for a couple of hours a week, kind of train your guys. But the other thing that a lot of them struggle with is also the data and how to put the data and where to put it. And that is also an important thing because 60-70% of the work is in data pre-processing and structuring it and putting it properly together. So I think one of the other things is these kind of more corporate workshops that are coming out and industry-specific courses. There's just one that was released by Nanyang Polytechnic with the CFTE. I was also one of the lecturers, which is on AI and finance. And what it does is it kind of gives you a little bit of the basics, but then really talks about the different applications and different use cases in that sense of AI. And that really gets people to think about which one may be useful and profitable to them. And I know that IMDA and others then offer some kind of subsidies, which I would encourage everyone to take on.
So how do we bring others on the journey? I mean, if we want to make this happen inside large organizations, inside, countries, we need to convince executives, we need to convince politicians. What are some of the ways that we can really help to bring them on board to make this happen? And I know it's probably worth just maybe going back to Ayesha, because I know that she has done a little bit with this.
Now, well, first of all, in terms of politicians, whether they put their money where their mouth is, there's so much excitement. Now, obviously, France just came out with AI for Humanity. President Macron just welcomed everybody to Viva Technology, the largest French conference on tech. I was just there. Right after that, I went to Oslo, and Prime Minister Erna Solberg said the same thing in her keynote for opening the address. And then I was in a small town in Malaysia. It's a province called Kuching, and it's largely rural. And the chief minister sat on a panel with me talking about AI at length. So I think there's a lot of excitement, but what happens is people are often sometimes disappointed because all this hype, they expect something really fantastic. And a lot of what we do is kind of work with them to bring it to something that's realistic and really valuable to the company or the...
Ofer, you're obviously from a country that's been doing this for a little while, really incubating technology. So what are your thoughts in terms of some of the things that we could borrow here in Asia and some of the mistakes that you made?
So again, I cannot speak on politicians because I'm just working at my CEO level. I'm not at this CEO level, Moody level and so on. But my experience is that you need to speak the same language as the business, basically. If you want to sell the idea, and I've seen it many times when I was younger, I was doing it the same, coming with a very technical presentation, similar to the one that Richard showed before, about CNNs and convolutional networks and everything, just to see the glazing eyes of my CEO and saying, what do you want from me? Right? So I think if we can transform the discussion into, I can use this type of technology in order to solve a problem that you have. Whether it's a chatbot, not just for the sake of a cool thing that I can present in the next conference, but a chatbot is a way either to reduce my operational cost or to increase my customer satisfaction. This is a business case. This is not a technical jargon, basically. So I think if we can try to translate what we know about the technology into the things that the C-level and the board level understand, I think we need to do a bit of education there. And I think this is our role as advocates in the organization. I think once we are there, it's much easier for them to say, okay, I like to buy this kind of technology.
Oliver, you work with fashion folks. What are some of the tricks that you have to help communicate the capabilities of machine learning into those folks?
I wish he hadn't used the word tricks. Okay. I work with a lot with retailers and brands today. Believe you me, every one of these retailers out there want to be an AI company themselves. All right. They have so much data, historical data, as well as new data that they get every other single day itself. It's a massive explosion of data. And due to the availability of these data, all of these scientists in this organization, we call them data scientists, they very naturally want to be able to process it, right? Because the information is useful to them. But a lot of these data scientists often underestimate the complexities of trying to build the models themselves. You could open source it, yes, you could also do that, but you could end up continuously stuck in the rut itself because your models are not robust enough or cannot scale to a different domain that you need to train on, for instance. And this is where the hard scientist comes in, the hard sciences versus the soft sciences. Yeah. So when we talk with the retailers and when we work with the brands, we normally work with them in order to help them understand the intent of what they want to do in the first place. If you know the intent, then with the right models that we can actually offer them, it actually gets to their endpoint a lot faster. A simple solution would be, doing a simple POC where, we could generate specific ROIs based on the ingest of the data that they provide to us. Most of it is normally unstructured. And we could definitely get to a certain level of accuracy, certain level of relevance very quickly, and then show the results. Now, we can also deploy that in the real world. If it works, we know that the model is robust enough to be implemented going forward.
Just to touch base some of the questions. The first question is whether AI is winning China is winning the AI race. I just read an article. It says almost 40+%, the largest amount of 48% exactly,
yeah,
of the VC funding of the world gone into China. Largest as a single country of investment gone in. So that could translate why it could be they are leading. I'm not sure. And the next, in terms of SME, I think I concur with the idea. Your main focus is how do you make money, right?
Yeah.
And you got to just make sure you focus in that, whatever business they're doing. AI has to substitute and help you to make sure you make more profit or you reduce your costs. So work with a good partnership, a startup, you can find many startups over here, anybody out there who can come and work with you a right business model so that they increase your profit or they decrease your costs, where you can do a good profit sharing, right? Unless you have a good AI practice in your organization, you have, if you can't afford to hire a good data scientist, forget about getting into that cycle because it's going to be a lengthy process, right? Because I assume you're a small SME where your profit is most important for you to run your business. So think about that carefully. And there was a question about what framework they want to use previously by one of them. You can take any of the famous frameworks out there available, all that given free. And a lot of source codes are given in GitHub. Hopefully it's going to stay like that.
That's awesome. Archives.
Maybe he can tell us a bit more after Microsoft, took over GitHub.
You missed the news. We bought GitHub this morning. So if you're a GitHub fan, I use GitHub more than I use Word. So if you're a GitHub fan, that's pretty exciting news. And hopefully I won't have to pay for my GitHub anymore.
Sure. So get the codes from the GitHub. Get it. You get that implemented. And if you think it is really, meets your pain point solutioning, any of the frameworks are fine. And then the other question is, what is the biggest problem? Today, the cleanliness of data, it is still the biggest challenge, right? So if you had a good big data or good data practice in your organization, getting a good, accurate algorithm is not an issue. If no, you may need to relook at your data practices within the organization. Increasing the accuracy, what I've seen in many organizations I work with, is not an issue. they could start with 85% because they were at least 70% using machine learning techniques. So for example, by adapting deep learning, they get 85. And over a period of time, with a good data practice and good feedback to the AI system that they have, they're able to push to 95, 96, and so on. It depends on a problem. So the journey in the AI, make sure it actually helps them to improve the productivity. So still data quality, I feel, is an issue. The rest is kind of taken care of. And I think it is, if you ask me, AI should be started yesterday. It should have started yesterday, right? Today it is about productizing it. Today about go to market with AI already, right?
So folks, I think that's a good thing to take away. I mean, I think, one of the things to take away today is data quality is fundamental. And if you get 12 months down the track and you haven't been collecting the data, and you haven't been doing a good job of looking after the data, you may well regret that because you're basically 12 months behind. So as you go away today, think about your data estate. Think about having a look in your data estate. And I really do appreciate you all coming out today. And we probably need to finish that up just a few minutes.
Yeah, I just want to comment that there's a major effort to democratize artificial intelligence. So a non-tech has the ability to have the capabilities that you would traditionally think a data scientist or an AI practitioner has. And that's extremely important for a lot of us in our industry, right?
So thank you all. I'm sure many of the speakers are around the next couple of days, so I'd love to have a chat. Thank you all for being here, and enjoy your couple of days.